Hi students, once again I am here for your online classes in engineering mathematics and module 5 in M4 we are just discussing, and this is the lecture 4. Already in lecture 3 we had discussed the first example, and that example was based on joint probability table, and you have been asked to estimate the expectation of x, expectation of y, expectation of xy, and these quantities you can calculate when you just prepare the chart of marginal probability distribution of x and y. On the basis of that, these three expectations you can calculate. After calculating the three expectations, we have seen that we have another very important quantity we have to calculate, that is covariance of x and y. So this was our first type of example, and that was very important example that we have done. Now we are going for next type 2 examples. So as you know that the total number of examples that we are covering here are type 1, type 2, type 3, type 4, type 5. Type 1 already we have covered. Now in this lecture I am going to cover type 2 and type 3. So let us begin. So we will see that what kind of data will be given and what is required to estimate in this type of examples. So let us begin. Now example type 2, you can see there is a JP table based again type 2. It is also, that means JP table will be given. First type also it is based on JP table only, and this type also is based on the JP table. So here JP table is given, and what has been asked to determine marginal distribution of x and y. This is not new for you. So marginal distribution of x and y easily you can calculate. So first I will concentrate on marginal distribution of x and y, how we are to calculate. Let's begin. So you can see that in this JP table we have first I will prepare the marginal distribution table for x. Okay, I will begin marginal distribution of marginal probability distribution of x. Now for the chart, you know that we will prepare a very simple chart. And here we record x values, xi, and here f of xi. And for x values, you have to go for the extreme left column in the table. And in the extreme left column, you can see under the x, the first value is 1, second value is 3, and the third value is 6. So it is 1, the first value, then the second value is 3, and third is 6, 3 and 6. And now to get the marginal probability distribution of x when its value is 1, the rule is what? You have to add all the entries along the row against the x value when it is 1. So against 1 you can see that what are the values. Just I will make a rough calculation here. It is 1 upon 9 plus is 1 upon 9 plus it is 1 upon 9, 1 upon 6, 1 upon 6 plus 1 upon 80 plus 1 upon 80. So when you add them, this will give you the fxi value when x is equal to 1. That's this. And very easily you can see that its value is 1 upon 3. So therefore, it is 1 upon 3. The marginal probability distribution of for x is x when it is 1 is 1 upon 3. Now next value is 3. Against 3 you can see that the values are 1 upon 6, 1 upon 4. Yes, I will write here 1 upon 6 plus 1 upon 4 plus the last value is 1 upon 12. And when you add these values, you will get, just you can calculate, it is 1 upon 2 means 0.5. It is 0.5 and it is 0.333. 0.333. Okay, this way the next answer is 1 upon 2. Either you write in fraction or you write in decimal. The third is 6. Against 6 you see what are the values? What are the values? 1 upon 18, 1 upon 12, 1 upon 36. 1 upon 18 plus 1 upon 12 plus 1 upon 36. So when you add all these, you will get the simplification, you will get 1 upon 6. Therefore it is 1 upon 6. So this way marginal probability distribution of x is obtained. And now next we will go for marginal distribution of y. Okay, next we will go for marginal probability distribution of y, random variable y. And the simple chart that we are going to prepare in the similar manner is here y, j is symbol that we will take, and these are the y values of random variable y, and here the symbol g, y, j we will take up for its probabilities. So here the values are what? Values of y are listed in table. You can see very easily that the values are 1, 3 and 6. So it's 1 first, then it's 6, then it is second value is 3, then it is 6. 3 and 6. And for 1, what is the probability for that? Because it is a case of the y, then you have to go for columns. The column values against 1 are 1 upon 9 plus the next value is 1 upon 6 plus the next value is 1 upon 18. 1 upon 9, 1 upon 9, 1 upon 9, 1 upon 6 and 1 upon 18. And when you add, you will get 1 upon 3. So that is 1 upon 3 is the marginal probability of y when its value is 1. Next, 3 against 3 column values. Now please, column values. So the column values that are listed under this 3, you see first value is what? First value is 1 upon 6, 1 upon 4 and then last value is 1 upon 12. 1 upon 4 and the first value is 1 upon 6, 1 upon 6 plus 1 upon 4 plus the last value is 1 upon, last value is what? 1 upon 12. And when you add all them, what you will get? So you will get the value as 1 upon 2. So therefore the probability for 3 is 1 upon 2. And last one, that's 6. When y value is 6, you can see when y value is 6, what are the values? Along the column under 3, it is 1 upon 18, 1 upon 12, 1 upon 18, 1 upon 12 plus 1 upon 12 plus last value is 1 upon 36. Last value is 1 upon 36. And when you add these values, you will get 1 upon 6. So therefore, probability when y value is 6 is 1 upon 6. So gentlemen, this is your first answer. For 1, determine marginal probability distribution of x and y. So these are the answer. Okay. So now, after getting this, we will go for the next part. The next is what is new. This already we had calculated, and we have prepared this chart for example 1 also. In most of the example, this is the preliminary thing that is required for all further calculations. But here, the second point is different. The second point is what? The second point, you can see that what is there? Are x and y, that is random variable x and y, statistically independent? Is the question. The question, are x and y statistically independent? What is meant by independent random variable? So just first we will discuss what is meant by independent variable, then we will go for next. So this calculations I will just wipe out, not required. This I will keep for some time. Okay. What is meant by the statistically independent variable? So for that, watch this. This definition. It is a definition. This particular definition is for independent random variable, or sometimes we call it as stochastic random variable. Stochastic random variable. So what is meant by stochastic random variable or independent variable? That means, what is the meaning of this? X and y, when they are reacting with each other in any process, are they reacting independently or they are dependent on each other? Once occurring or once happening affects the happening of the other, or totally both are independent, once happening has nothing to do with the happening of the other? That is the question that we are going to discuss here. So that means very easily you can see by this that there will be two types of things that we will accept. What are those? First, there will be the random variables that are defined for any random experiment, may be dependent, or they may be independent. They may be independent. So dependent we will forget for some time. We will go for what is meant by independent. So first we will define independent. As you see on the board, what is the independent random variable? See, the discrete random variables x and y are said to be independent random variables if, here, for this we are giving a definition, if what it says, that probability, joint probability, it is joint probability, not the single probability, joint probability, when x value is equal to xi and x is equal to xi and y is equal to yj, this probability is equal to independent probability of the random variables. That means probability of x when its value is xi into probability of y when its value is yj. So that means if the joint probability is the product of the independent or individual probability of both the random variables in all the possible pairs that we are discussing in any example, if in every case you find that if you multiply the individual probabilities of the random variables, you will get the joint probability. You will get the joint probability in each case. That means what? What is the individual probability? Where will you get? These are the independent probability. For example, you see 1 upon 3 is the independent probability of x when its value is 1. It is the independent probability of 3. It is the independent probability of 6 for values of random variable x. Similarly, independent values of y's are also available. So independent values of probability for random variables are available in marginal probability distribution table. So these are independent. So what it says, when you multiply these, for example, when you take first 1 upon 3 into 1 upon 3, suppose if you multiply 1 upon 3 into 1 upon 3, so what you are multiplying? You are multiplying when probability of x is equal to 1, okay? When probability of, when value of the, sorry, probability of when x is equal to 1 and y is also equal to 1, then this probability must be equal to 1 upon 3, 1 upon 3 means 1 upon 9. But you know that this probability is nothing but J11. That means J11 is equal to 1 upon 9. So that means in the table, if this value is found in the table for against 1 1, if this value is found for J, that means that what we are asking here, this formula, that we have verified for first pair, that is 1 1. Similarly, you can go for J12, J13, like that. Here J11, these are the ranks I am writing here, I values, I J13, here also, I value J1, 1, 2, 3, and J values are 1, 2, 3. So I mean J11 means first value, J12 means first value, second value, first value, third value. So this way all pairs you have to consider, and in each case the corresponding joint probability value in form of in the notation of J should be there. So let us check that already table is available. Let us check whether this can we get in the table. Just go back to your table. See 1 1. So see, here it is 1, here it is 1. So x is 1 here, y is 1 here. So 1 1. What is the J value? 1 upon 9. What is the product of individual 1 upon 3, 1 upon 3? 1 upon 9. That means for the order pair, for what order pair we have taken? 1 1. The value is absolutely according to the definition of independent random variable. So you have check 1 1, you check for 1 3, you check for 1 4. If individual probability of 1 upon 3, if you take and multiply with second, that is for second, that is 3, 1 upon 2, then what you will get? You will get the value as 1 upon 6, and it should be the value in the table for 1 against 3. You see, 1 against 3. So 1 against 3, what is the value? Second value after 1 upon 9 along the row, 1 upon 6. Here also it is 1 upon 6. So this way all the possible pairs, how many pairs, please tell me? When there are 3 values for x, 3 values of y, how many x comma y pairs you will get? 9. So 9 calculations you have to do here, and for each calculation actually okays or actually gives you or approves the corresponding values that are listed in the table, then these two variables, random variables, are said to be independent. So therefore that we will begin in a systematic manner, because we have to answer the question this way. We cannot do it, you see, in this random manner. We have to systematically, we have to make the calculation. So I will go for this calculation. So this is the definition. Further I will discuss the definition later. First, whether they are independent or not, that we'll check by calculations. Let's begin. So first I will take up one by one. Okay, I will begin here by first calculation. So first I will take up J11. So what is J11? Let's see in the table. It is J11. So J11 in the table is, J11 in the table is 1 upon 9. Okay, this we have taken. Now we'll check up what is the f of x when its value is 1 into f of j of y. Sorry, symbol should be taken capital. G of y when its value is 1. So you can see that when 1, probability is 1 upon 3, and when it is 1, probability is 1 upon 3, and answer is what? 1 upon 9. So you can see that this is okay. Next we will go for second, and J J12 is equal to what? In the table you can see J12 is equal to 1 upon, what is this? 1 upon J1, sorry, it is J12 means it is J12. J12 means for 1 and 3 values. 1 and 3, what is 1 and 3 values? 1 upon 6. So J12 value is 1 upon 6. So let us calculate when F1 means X is again equal to 1, okay, into when G Y is equal to, for 2, second value is what? Second value is 3. When Y is equal to 3. So what you will get here? So when X is equal to 1, it is 1 upon 3. X is equal to 1, it is 1 upon 3. When X is equal to, second value we are taking 3, it is 1 upon 2. And you can see that answer is 1 upon 6. And you can compare that, yes, it is also 1 upon 6. It is also. That means it is also 1 upon 6 and listed value. So please here I will once again tell you that P of xy is nothing but it is written by two symbols. Fxy is equal to, you can write this as f of x into g of y. This way also you can take. Or another symbol is there for you, what? This is nothing but Jij is equal to fxi into gyj. So these all symbols of course are valid. We can use any symbol that is there. Okay, after getting this, so two we have, this with this we have compared, this with this we have compared. Now we will go for last one. So last one I will take up here. So last one is what? J12, J11, J12, and now the third we are taking J13 is equal to. Now J13, what is the J13 in the table? J13 means one is, first value is 6 and third value is, first value is 1 for x and third value is 6, 1 and 6. Again 1 and 6 if you see, so what is the value listed there? 1 upon 18. So it is 1 upon 18. Yes, now we will check through this. 1 upon 3. So therefore now I will take up, it is P, I will take when f x is equal to 1 is equal to into g y is equal to, now we are taking third value. What is the third value here? So third value is 6. So that is y is equal to 6. So what you will get here? E is equal to, yes, when f x is equal to 1, of course it is 1 upon 3. And when it is y is equal to 6, it is 1 upon 6. And that is equal to 1 upon 18. You see in third case also 1 upon 18. In third case also you have seen that it is 1 upon 18 and 1 upon 18. That means with 1 we have verified all the pairs of y, that is 1 with 1, 1 with 3, 1 with 6. Similarly you have to go for this, 3 with 1, 3 with 3, 3 with 6. In all cases if the same type of pattern is present here, 1 upon 6, 1 upon 6, 1 upon 9, 1 upon 9, 1 upon 18, 1 upon 18, then the variables are said to be random. Okay, now if we will go for the next. So I will take up 1, 2, 3 we have finished. So next I will go for the fourth one. The fourth calculation that I am taking is with 3. So that means you are taking J, 3 is, ranking is 2 and 2 with 1. 2, 1 I am checking. And here 2, 1. In the table 2, 1. 2 is 3 and 1 is 1. So against 2 and 1, what is the value? 1 upon 6. You can see 2 and 1. 1 upon 6. So it is 1 upon 6. Okay. Now this side we have got. Now this side we will take. So this side is what? Here that is equal to, yes. So f when x is equal to 2 means 2 under it is 3 into g y is equal to, yes, what is y is equal to? Y is equal to, for 1, y is equal to 1 is 1 when y is equal to 1. So when x is 3, the probability is 1 upon 2. into when y is 1, y is equal to 1, the probability is 1 upon 3. E is equal to 1 upon 6. E is equal to 1 upon 6. So very easily you can see that this value also exactly same. That means it also is verified in favor of the definition. Let us go for, so in this way you have to try it with this, try with this, try with this. Let's begin. So then J rank is 2 here, 1 you have tried, not 2. So J22 you will take up. So J22 is what? In the table. In J22 if you take up 2 is 3 and here 2 is also 3 pair. So when you take 3 pair in the table, here 3, there 3. What is the value listed for 3? It is 1 upon 4. It is 1 upon 4. Now we will go for the other side of the definition. That is the product of the probability, individual probability of x is equal to, here f of 2 means x is equal to 3. X is equal to 3 and we are comparing with this, that is y is equal to into y is equal to, that means y is equal to what? G of y is equal to 3. So this value, so it is 1 upon 2 and 1 upon 2. So when you multiply this probability 1 upon 2 with 1 upon 2, what you will get? 1 upon 4. And easily you can see that this also is confirmed. Yes, gentlemen, see how the results are very much in favor of the definition. So this we have completed. This, the last is what? So in the last case we will come here. So now in the last case, that is 6 we are taking. The 6th value we are checking. So that is J23. It is J23. What is J23? 2 is 3, 3 is 6. So 3, 6 pair. So look in the table, 3 and last one 6. 3, 6. What is the J value listed for this particular box? It is 1 upon 12. It is 1 upon 12. Okay, this is the J value. That means joint probability. Now we will take up the individual probability. So individual probability is what? It is f of x is equal to, when it is 2, it is 2 means 3, x is equal to 3, when rank is 2, it is 3, into g of y is equal to, what is rank? 3. When rank is 3, what is the value of y? 6. Okay, that is equal to, in the marginal table you can see that the probability of 3 when x is equal to 3 is 1 upon 2. And when y is equal to 6, it is 1 upon 6. So what is the answer? 1 upon 1. So this way, here also you can see that the things are in favor of definition. That means J value, this J value is equal to the product of this, which confirms, which actually goes in the direction of confirmation of variable being random. Okay, this we have test for this. So this is what is last, this is left. Now first we will take up these tests. So 5, 6, because 9 tests we have to take up. 3 into 3, 9. So total 9 such calculations we have to make up. Then the example is complete. So, okay, after 6th, 7th we are taking. In the 7th, J31 we will take up. J31. Look in the table, J31, x is 3 and y is 1. So what is the value here? What is the value here? 1 upon 18. You can see in the table, it is 1 upon 18. So it should be equal to f of x is equal to 3. 3 means 6 when x is equal to 6 into g of y is equal to 1. Because 3, 1 we are taking, 1 means it is 1. Y is equal to 1. Value of y is 1. And exactly you can see that f of x when it is 6 is 1 upon 6 into f of g of y when it is 1 is 1 upon 3. So what is the answer, gentlemen? Yes, is 1 upon 18. So in this way, once again you can see that it is also in the direction of confirmation of the results in favor of this definition. Okay, this is this. Now next, go for next. That is 8. Yes, in 8 we will go for J3 one we have taken. Now J3 2. That means J3 2. See, this is 3, this is 2. Against 3, what is the value of J3 2? 3 means 6 and 2 means 3. 6 3. Where is 6 3? So look in the table. Where is 3 6? 3 and 6 middle value. So what is the box value? Box value is J value. So that is equal to, when it is 3 6, it is 1 upon 12. It is 1 upon 12. Okay, this we have got. Next we will go for the other side of the formula, that is fx into fxi into g of y. Fx, so fx is 3, 3 means x value is 6 into g of y, that is the y value when it is 2, 2 is 3. So when it is 6, it is 1 upon 6 into, when it says y is 3 is 1 upon 2. And what is the answer? 1 upon 12. What is? Here also 1 upon 12. Here also 1 upon 12. Left hand side value and right hand side value both are equal. So this also confirms our requirement. This is how you are going to take up. It's very simple. And last 3 will compare with 3. So this is the last one. So let's go for that. J here 3 3 we will take. J 3 3. So see what are the values? J 3 3. So in the table, when you see y is equal to 3 3 for 3 6 and for 3 6 6 6 pair you have to take up 6. So y x is equal to 6 and y is equal to 6 is the last. So last corresponding box value of J is what? It is 1 upon 36. It is 1 upon 36. So okay, now when third, so what are the x and y values there? What are the x and y values are there? You can see when the rank is 3, x value is 6. When rank is 3, x value is again 6. When you take these values, what are the probabilities? Probability for x is equal to 6 is 1 upon 6 into, when y is equal to 6 is 1 upon 6. And what is the answer, gentlemen? What is the answer? 1 upon 6 into 1 upon 6 is again 1 upon 36. So this way, once again you can see that you have confirmed it. You have confirmed it. So that is what we have got. So this way, gentlemen, we are getting that all these values are confirmed, and now very easily all the 9, one with this and this and this value with this and this value with this, all these 9 verifications we have conducted, and in each verification we found that this particular definition holds perfectly good. Therefore, now you can declare that the random variable x and random variable y are perfectly independent. So gentlemen, here some more. Of course, this example is complete, and this is for 6 or 7 marks. Easily you can score by this. So therefore, this example is complete. But once again, I want to go for the definition. See here. In the definition, once again, see what the definition says. The discrete random variables x and y are said to be independent random variable if the ji value, so jij value, here it is written p x is equal to small x, p y is equal to p x is equal to small x, comma y is equal to y small y. It must be equal to the individual product of the individual probability. That is, p of x is equal to x into p of x y is equal to y. So this way, this definition we have taken. But here, please see the next line. In case of joint probability, if x and y are independent random variables, then this must be equal. This must be equal. So other symbols are also been listed there. So be careful about the symbols, because for probability more than one symbols are used in different cases. You should not get confused with. And actually this is the definition and this is the example. Definition of course will not be asked, but according to definition we have to work out the problem. Okay, so now this is the case that we have done. Okay, one more extra thing you have to see here, that if these variables are, when these variables are independent, each pair that is obtained out of x values and y values confirms this definition, each pair, then the variables are said to be independent. When they will become dependent, therefore this note please take very carefully, this particular note. What the first point says, if x and y are independent, then each entry in the table, what Jij entry is in the JP table is equal to the product of the corresponding individual probability values. So that is what is this. This we have actually seen. But if suppose if above is not true, what is meaning of this? That if this relation, left hand side and right hand side values, if this relation, this or this relation is not good or not correct in favor of at least one pair, suppose out of 9 pairs any pair goes against the formula, against the definition, then the variables are said to be dependent. This is very important. That means when you are working all the 9 pairs, suppose first confirms, second confirms and third confirms, then suppose the fourth one when you work out, you find that it doesn't hold good. That means the Jij value is not equal to Fxi into Gyj. Then further calculation is not required. Here itself we have to say that the variables are dependent. That means they are not independent. So therefore, if you want to prove dependent, only one pair you produce out of the all possible pairs which goes against the definition. One pair sufficient, at least one pair. But for independent, to prove independent, you have to confirm the results of all the possible pair in favor of the definition. That's very careful, you have to know. So therefore, sometime this is a supplementary questions in the exam. That means all things will be calculated, expectation, and simply he will say, are the x and y are dependent or independent? So for that, mostly if it is independent, all pairs you have to work out. But for dependent, if you want to prove, one pair you select where result goes out. All pairs you are not required to work out. So this is what is there. So this way, this is the type 2 examples in which the stochastic variables or independent variable type of examples we have to deal. This type 3 independent variables are there or not, that we have to verify. Okay, this is what we have done. Now we will go for the next type of example, that is example 3. So in type 3, what kind of examples we are going to take up? So please, once again I will revise what we did in type 1. Type 1 JP table was given, and out of that table what you are required to calculate or estimate. You are required to calculate or estimate the expectation of x, expectation of y, expectation of x and y, and then you have to find out the covariance. But in example 2, you have to go for marginal distribution chart, and then you have to work out, you have to see that the random variables are independent or not independent. That's what you did. Now type 3. That's what is in this basket, type 3 basket. What kind of examples we are having? Let's go. First I will bring the example on the screen. So this is the example. Now look at the example, read carefully. What is this example? Very easy. It is lengthy. It has a lot of you see stuff is there, but read it. The probability distribution of two discrete random variables x and y is given by fxy is equal to k 2x plus y. Yes. Here, first thing, joint probability table is not given. This one thing. But the joint probability values, how they are related with independent or single random variables, that relation in the form of function is given. So what is that? The function that is given is f x comma y. See, whenever I write x comma y means it is what? Jij. This is the another symbol. X comma y is equal to k into what is given? Just see the relation k into 2x plus y. 2x, small x is the value of random variable x, plus small y means the value of random variable y. So that means each Jij value for all the possible pairs of x and y, you will get by this relation. That means how many values of x are there, how many values of y are there. If that is known, on the basis of that values, putting the corresponding values of from the each possible pair, what you will get, that will become the value for Jij. Of course, k is a constant which is unknown. So therefore, now read the problem. The probability distribution of two discrete random variable x and y is given by this relation fxy is equal to k into 2x plus y, where x and y are integers. So here details of, I will write this here. You can take this as another, this symbol also is very important. So Jij. Okay. So now what is x values and y values are not given simply. But what is said in the example, read carefully, where x and y are integers. They are integers. 1, 2, 3 months, 1 month, 2 months, 3 like that. Such that 0, that means 0 is less than x is less than, it is less than x and less than 2. 0 is less than or equal to, sorry, equal to. 0 is less than or equal to x, 0 is x is less than or equal to 2. Means it is the interval of x that is given. And similarly for y, it is 0 is less than or equal to y value and less than or equal to 3. So this is the interval for y. On the basis of that, you can get what are the values of x. So random variable x will take these values. 0 of course is the value, then 1, and the last value is 2. So these are the possible values that you will get. And what are the values for y? So for y, the values are random variable y will take, of course, 0, 1, 2, and 3. That means it will take 4 values. It will take 4 values. So according to definition, these are the values. So this is your data. This is your data. So on the basis of this data, the following things you have to find out or you have to calculate. What is the first thing? You have to find out what is the value of k. This constant k's value you have to find. Next, find the marginal probability distribution of x and y. So fx I, gy, j value chart you have to prepare. This is the second. And when you will get the marginal probability distribution values? When you prepare the joint probability table. That means for second, first you have to prepare the joint probability table. Then only you can get it. Second. The third, show that random variables are dependent. Once again, the previous example. That means at least one pair you have to prove that doesn't satisfy the definition or that is not in the favor of the definition. That's that. So it is very simple example. So how to work out? So here let's go one by one. So one I will show here very easily that suppose you want J11. First value you want J1. J11 is equal to K 2x plus y. So J11 means this is 1, this is 1. This is the value 1 and 1. So if you take up these values 1 and 1, that means first pair that you have to take up with 0 you have to take 0. This is the x and y values. When you put these values here, what you will get? K into, when you put x is equal to 0, it is 0 plus 0 means it is 0. So that means first box value in the JP table will be 0. Next, With 0 you have taken 0. Now you go for J12. J12 means this is 1. You see, please, these are the ranks 1, 2, 3. This is the values of I. These are J. 1, 2, 3, 4. So now when you take J12, J12, this is the 2. This 1, 2, 3, 4 values of Y are available. Okay. Now suppose, now if you take up 1, 1 you have taken 1, 2. 1, 2 means 0 and 1. So that means in this you have to substitute. Next, what you have to substitute? 1, that is 0, and 2 means 1. This you have to. When you substitute here, what you will get? When you substitute 0 plus 1 is equal to 1 into k is k. 1 into k is equal to k. So this is how you will get it. So this way, J11, J11, J12, J13, J14. Then J21, J22, J23, J24. Then J31, J32, J33, J34. So all possible J values you have to calculate. And you see, when you are calculating, how many pairs you are covering? 12 pairs. Why 12? Yes, please gentlemen, tell why 12? Because there are 3 values of X and 4 values of Y. 3 into 4 is equal to 12 pairs you are getting. The first pair you have got 0, 0, second pair you have got 0, 1, third pair will be 0, 2, fourth pair will be 0, 3. So there will be 4 pairs with 0, 4 pairs with 1, 4 pairs with 12, 4 plus 4 plus 4, 12 pairs you have to work out. And this, of course, is so simple that there is no need to write this way. Directly you can write. For example, when you take, because you keep in your mind, of course, if you are confused, write all the pairs. I don't mind. Even examiner don't mind if you write all the pairs, all 12 pairs. But unless you go by this way, it is easy. 0, 0, first value. 0, 1, second. 0, 2, 0, 3. These values you substitute and get the value and put the first row completely you can fill up. Okay. And then you can go for 1, 0, 1, 1. This way. So in this way, all 12 pairs you can cover and 12 values you will get. By that you can prepare the table. Okay, if first work this we will take up. So therefore you see here now on the screen you can see the same thing is already available. X values are 0, 1, 2, Y values are 0, 1, 2, 3. So just for a sample I have listed some of the pairs out of 12. So some pairs I have listed 0, 0, 0, 1, 0, 2, 0, 3. And lastly it is 2, 0, 2, 1, 2, 2, 2, 3, and this way all the pairs you will get. So 12 pairs you will get. Some pairs I have listed in the slide here. So out of this, what you have to do now? You have to prepare the table. So now if you go on preparing, so this is the formula. What you are doing? To prepare the joint probability table using the values, these values, one by one. Each pair you have to take once and you have to substitute where? In this relation. That relation I have listed here, and that is also in the slide. Okay, when you go on substituting, what you will get? You will see that this is the table. This is the method. That means in examination, first you have to prepare the table. And there in table, you have to go on putting the values one by one. For example, this table, suppose you have prepared in your answer sheet. Then first value what you will put? For 0 and 0, for 0 and 0, the value is 0. So the first box here, the first box will be 0. Now in the second box, next box, what is when it is 0, 1, 0, 1. So when you substitute 0, 1, what you will get? You will get k. So next box is k. Now the third box, I will work out for at least one row. I will work out J13. See here. J13. So when you take J13, it is 0 and for 3 it is 2. So 0 and 2 you have to put up. What you have to put up? 0 and 2 in this relation. This is the relation. When you put 0 it is 0. When you put 2 it is 2. So it is 2k. So therefore in third box of the chart against what 0 you are working, 0 you are taking. So against that the first is 0, second is k, third is 2k. And last, when that is J14. When you take J1, 1 is 0, 4 is 3. So here you have to take up the pair 0, 3. When you put 0, 3 in this, 0 is 0. When you put 3, so it is 3k. So next is 3. In this way you have to complete all the boxes. You have to fill up all the boxes in the JP table. And if this way you can do, then what you will get? See, you will get this. Already answers are ready. First you see, first row you can observe there. First row you observe. What is there? First row is what? First row is 0, yes. Then k, yes. Then it is 2k, yes. It is 3. We have worked out with 1. Now go for 2. When you take a second, that is 1 0, 1 1, 1 2, 1 3. Go on putting 1 by 1, you will get all the values against 1, x value 1. Along second row you will get. So what is the second row? 2k, k, 3k, k, that's 4k. Work out, you get it. This is very simple. And when you have completed the second row, for third row you have to go for this with all these. 2 0, 2 1, 2 2, 2 3. One by one you put what values you will get by putting these all pair values in the relation. You will get first what? 4k, then 5k, then 6k. This way your JP table is ready. Your JP table is. So this is, gentlemen, what is the requirement. Of course, you just don't forget what we had been required to us. You see, when you go back, you will see that find the value of k is still not we have got. But to struggle for k, these all calculation you have to make. All these calculation you have to make. Then you will come to the k. Now when this table is prepared, already when this table is ready, then you can see that now this table is ready. How to find out k? Now what you have to do? Now you have to go for marginal distribution. How will you prepare the marginal distribution? So gentlemen, I will remove this. How will you go for the marginal distribution? Okay, in the case of the marginal distribution, you have to add up along the row. If you add up, you will get fxi values. Along the column, if you add up, you will get the marginal distribution for y values. So therefore, I will prepare. So what I will do for convenience, this table is already with you. You see. This table is already with. Here one extra row and column I will introduce. Extra row and column I will introduce. And here I will take up the summations. It is 1, it is 0, 1 and 2, 0, 1, 2 and 3. So these are the 12 boxes that we have completed. So now, so I will not write all the values because in the chart available here, what are the values? All these values you add and fill up this column. Yes, 0 plus k. I will write 0 plus k. I am taking this row, this particular row I am taking. 0 plus k plus 2k plus 3k plus 2k plus 3k. So what is the result? 5k plus k, 6k. So therefore here you can write 6k. So this is nothing but marginal probability when x is equal to 0. So this way you get all the marginal probability or fxi values for corresponding xi values. So this way if you go on, you will get 5k here. Just you add in the table, see, and you can get 7k. So this is your marginal probabilities for x. And when you add column values, if you go this way, column values against 0, because it is x values and these are value values, against 0 if you go and add up, you will get gyj. You see the symbol here is fxi and symbol here is gyj. So you will get gyj values, that is against 0. If you add up, what is there? 0 plus 2k plus 0 plus 2k and plus it is 3k plus 3k. So what is the value here? It is 5k. It is 5k. Sorry, 4k. I will take up not 3, it is 4k. So therefore it is not 5k, it is 6k. So you got this. Now against 1, what are the values? Just see in the column. Against 1, the values are, what are the values? Just see against 1, it is k plus the second value, gentlemen, 3k. Yes, second value is 3k. Then what is the next value? It is the k, 3k and 5k. So what is the sum? 8k, 9k, 9k. And against 2, if you take up, it is 2k, 4k. Look in the chart, 2k, 4k, 2k, 4k, and it is 6k. And it is 10, 12. It is 12k. 12k. And against 3, you can get this as when you take up against 3, it is 3k, 5k, 3k, 5k, 3k, 5k, and one more value is 7k. So when you add up 7 plus 5, 12, 12 plus 3, 15k. So this way you will get the marginal column and marginal row is complete. And these will be your marginal probability distribution for X. This row will give you the marginal probability distribution of Y. So this is what next. So I think it is already there, you can see. So that way you can get. So here, gentlemen, one important thing is this, that when you add all these values, what you will get, it is 42k. You can check. This is mistaken. Add these values, 4k, 4k, 5k, 6k. Yes. So its value is 22k, sorry. It's 22k. 6k, 15k, I have made some. So one value I have left everywhere, I think. So please add once again. K plus 2k plus 3k is 6k. 2k plus 3k plus 4k plus 5k is 14k. 4k along the row I am taking. 4k plus 5k plus 6k plus 7k is 22k. So this is 14. Sorry, I have made a mistake. And it is 6k is correct. And when you add all these, you will get 42k. When you add all these, that is 6k, 9k, 12k and 15k, you will get 42. So both results tally here and this 42k you will get. So this chart is already visible. So please, previously what I have calculated, there were mistakes. One value I had not taken in addition, so therefore that was not correct. Now it is correct. 6k, 14k, 12k. This way you will get this. So this is exactly your got. After getting marginal distributions along with the JP values, that is J values, you can now go for answering your question. The first question is, what is K? The first question was, what is the value of K? You know that when you take up this one, you have to take sigma fxi is always equal to sigma gyj. You can observe sigma fxi when you add all these values. Or you add this value, always it is equal to, they are both same, and here this is equal to, in the definition it is given, this is equal to 1. Value is what? 1. So therefore it is 1. So 1 means, that means this value is 42k. The sum of this is 42k, this sum of this is also 42k. So therefore this 42k must be equal to 1. So this gives you the first answer, that k is equal to 1 upon 42. This is your first answer, A. This way you have to get the first answer. So this is what you are going to take up. Now this is your first answer. Now go for, what is the second requirement? Just see here. Yes, first find the value of k. Constant k is 1 upon 40. Find the marginal probability distributions of x and y. Already there. So here you prepare the chart. Yes, you put the chart. Yes, put xi values and fxi values. Okay. X values are 0, 0, 1 and 2. 1 and 2. This is the marginal probability distribution of x. Okay, 0, 1, 2. For 0 it is 6k. 6k means what? K is 1 upon 42. Means it is 6 upon 42. For 1 what is the value? 14k. 14 upon 42. And for 2, it is 22k, that is 22 upon 42. So this is your first. You can simplify this. 6 upon 40 is 1 upon 7, and 14 upon 42 is 3 upon 7, and it is 11 upon 20, 11 upon 21. So this way, this is your first answer. That is find marginal probability distribution of x and y you have got. And marginal probability distribution of y, yes, marginal probability distribution of y, how will you get? Marginal probability distribution of y you will get by preparing this chart. Yj, Gyj, and here what are the y values? 0, 1, 2, 3. 0, 1, 2, and 3. What is the marginal probability for 0? 6k. 6k means 6 upon 42, because k is 1 upon 42. For 1 it is 9 upon k, 9 upon 42. And for 2 it is 12 upon k, 12k, that's 12 upon 42. And 3, 15k means 15 upon 42. You can simplify if it is there. 1 upon 7, I think this is 3 upon 14, I think it is 2 upon 7, and it is 5 upon 14, like that. I think, just check it. So this way, the first answer, second B answer you have got, find the marginal probability distribution of x and y. So this is. Now show that the random variables are independent, that is, at least for one pair fxi and gyj, you must have a value which is not equal to jij. For that, any value you can take from the table. So let's go back to the table. So let's go back to the table, and this last answer also will confirm. So okay, for that is there. So now to work out this, any one pair you have to take up. They are dependent. One pair is sufficient to prove. So you take 0, 0, and 0. That means this you check out. This is jij value. So please, what is the jij value? In this case, J1, 1 I am taking. J1, it is 1, 2, 3. It is 1, 2, 3, and 4. 1, 1 I am taking. J11 is equal to 0. J11 is equal to 0. And check fx is equal to 0 into fy is equal to 0. Fy is equal to 0. So fx is equal to 0. What is the value here? Here you will, in the marginal table you will get, or here you will get. In the case of 0, it is 6k. That is equal to 6k, means 6 upon 44, means it is 1 upon 7 into 1 upon 7 into it is y is equal to 0. Y is equal to 0. Yes, y is equal to 0. 6k again. Here also 6k. Here also 6k. 6k means the first value 6k means it is 1 upon 7. And you can see that it is 1 upon 49. Whereas the corresponding joint probability value is 0. Both are not equal. You can see this and this when you confirm that Jij, J11 is not equal to fx is equal to fx1, I will call it, and into jy1. So they are not equal. So therefore these values are not equal. So therefore if at least one pair doesn't favor our definition, then we will say that both the variables are dependent. Both the variables are dependent. They are not independent. So gentlemen, here you see there were total 12 pairs. Out of one pair we have calculated 11 pairs. What they are doing, we don't worry, because already one pair has confirmed that they are dependent. Suppose all the rest of 11 pairs favors, then also the variables are said to be dependent only. So this way the last question also has been answered. Once again I will take up to the problem. So see here the problem, first answer, k is equal to 1 upon 42. Marginal probability distribution tables we have prepared here, and then show that the variables are dependent. For that one pair we have taken here, and we have confirmed that this pair doesn't favor the definition. So therefore the variables are dependent. You have to write here. You have to write in the sentence. Therefore, the variables are dependent, and or you write the variables are not independent. Carefully you have to write. This way the answer is complete. Okay, this is what we have taken. Now here the problem is complete. Problem is complete, and all calculations I have shown on the board. So now next one thing I am going for extra work. So this extra work means what? This extra work means, even suppose all those questions will not be there, directly he will give you the table. This table will be given, and he may ask you what? He may ask you that, of course this question we have worked out. He may ask you to estimate. What you have to estimate? First, the expectation of x, expectation of y, expectation of xy. Instead of asking all this, giving this table, he may ask you this, and on the basis of these three you have to find out the covariance of x and y, and you have to find out the correlation of x and y. This also is possible. This way, this particular thing I want to do yourself, and you please complete it, and then we will see that how in the next type of example. Once again, in some example I will work out these two. What? Expectation of x, expectation of y, and expectation of xy, and then covariance of x and y. You remember the formula. What is the formula for covariance of x and y? That is, covariance of x and y is equal to, here I will write, covariance of x and y is equal to, I will just give you the formula. Expectation of x is equal to mu of x is equal to, it is sigma f of x into x values. Expectation of y is equal to mu of y is equal to sigma gy into y values. And similarly, expectation of xy is equal to, just I am reminding you the formula. Expectation of xy is equal to sigma, it is sigma, it is x, y and ji values, xi and ji values. So for this you refer the marginal probability distribution table of x, marginal probability distribution of y for second, and for this you have to refer the JP table and these three calculations. When you get all these three values, then the covariance formula, covariance of x comma y is equal to expectation of xy, that already you have calculated, minus expectation of x, I will take up this symbol, and expectation of y, this symbol. So this you can calculate the covariance. And after getting covariance, now I have not taken correlation. In next type of example, I will make the calculation practice for the correlation also. Here I will not take up. In next example I will take up. So this way we have got these all things. Thank you.